So the first thing we're going to start, and remember, we're trying to verify that these inequalities are equal to each other. We already know they do. We just need to verify, aka prove. So I like to work with the left side of my equation and prove that this side is equal to that side. By looking at this, I could see that this tangent of x plus 1 and the secant of x minus 1, if I have my identities in front of me, I know that these are Pythagorean identities. So I know that the top part, tangent squared x plus 1, is the same thing as secant squared of x. I also know that the bottom part, the cotangent squared of x minus 1, is the same thing as cotangent squared of x. And if you really want to see what's going on, you could separate it. But I want to point out that we needed a secant squared of x, and we have that. What we want to get rid of, or we want to change, is we want to get a tangent squared x, and we have a cotangent. So there has to be a way to do that. It might be easier for you to see if we separate it into two separate pieces. Think of it like 1 over cotangent, like this, and then we know that 1 over cotangent is an identity, and now we could have that secant squared of x is the same thing as tangent squared of x, because that's one of the identities that we know, and we have just verified that the left hand side is the same thing as the right hand side by our identities. For this problem, I'm going to change everything to sine and cosine on the left side. 99% of the time, that is what I recommend. It makes it much easier to do it. The reason it makes it easier is because it's easier to see things that could cancel out, that you could manipulate. It's also what most people do when they're trying to verify things is change it to sine and cosine, just to work faster or easier. Sometimes it might be longer, but at least you have a chance of not making mistakes. So we know that tangent is the same thing as sine of theta over cosine of theta. So I'm changing that. I'm also changing the cotangent to be cosine of theta over sine of theta. All of that over another tangent, which is going to be sine of theta over cosine of theta. I want you to look at the top part, and I want you to realize that when I'm adding two things, anytime I'm adding two things, technically there are two fractions, I need a common denominator. So I'm going to multiply both top and bottom to get a common denominator. So this side needs a sign, and I'm going to put it in the middle. But I want you to understand that I'm basically multiplying top and bottom when I put it in the middle. So now I'm going to have sine of theta squared, because I have two signs right there, and on the top I'm going to have plus 2 cosines of theta because I multiplied, and on the bottom I'm going to have cosine theta sine theta, all of that divided by the sine theta over cosine squared theta. And now that I have that, I want you to realize or see that this is a Pythagorean identity, which we know that sine squared theta plus cosine squared theta equals 1. So now we're going to have 1 over cosine theta sine theta, all of that over sine theta cosine theta. And the next step, which I'm going to go to the side because I have no room, is I'm going to leave the numerator fraction like it is. So I'm going to have cosine theta sine theta. I'm going to take the reciprocal of the second one. So the cosines are going to go top and the sines are going to go on the bottom. And then these cosines could reduce because they're being multiplied. And now I'm going to have 1 over sine squared theta because I have 2. So this sine times this sine gives me sine squared theta. And we know that 1 over sine squared theta is the identity of cosine squared theta, because we know that 1 over sine is equal to cosecant of theta, or we know that cosecant over 1 is the same thing as sine theta. Same thing. So that checks out. So I gave you time to do this in class. So again, if you were absent, do me a favor, work this one out, pause it, and then I'll show you the answer and explain it really quick. So let me cover this. So basically what happened here is I changed these tangents a lot like the last one into sine and cosine. So this tangent of x became sine of x, cosine of x. Same thing for this one, sine of x over cosine of x. Since the top here is a two fractions, we put a 1 under it and we get a common denominator. So I multiplied this sign, top and bottom, by cosine. And then this, I just went sine of x times sine of x. There's no plus and or minus sign, so I could just do multiplying. So I got sine x squared, sine squared x. And for the numerator part, I basically got this sine of x over cosine, sine of x cosine with the denominator of cosine. So both of them have a cosine. And since both have a cosine, I could make the top into one big fraction instead of two separate ones. So I put it all over one cosine. And I want you to notice that now that both pieces, that's my highlighter, that both pieces have a sign. So that lets me factor out a sign down here. Okay. But apparently, before I factored out the sign on the second to the last step, what I did was I got this fraction, and I changed the division sign to multiplication and took the reciprocal of this one. Then I factored the two signs out. And once I factored two signs out, these two cosines could cancel out. And this sign and one of these canceled out. So that means on the numerator, I had 1 minus cosine x. And the denominator, I had the 1 left over of the sine x, which is what I wanted, and I verified it. I'm not saying this is the only way to do it. This tells you every single step. There, some of you could probably skip a couple of these steps. I'm going to say you could probably skip this step and this step very easily. So for this problem, what I'm going to do is multiply this side by 1 minus sine of x because I want to get a common denominator. I want to make it into one big fraction. So this is going to be 1 plus sine of x. So I want the denominator of both of those to be 1 plus sine of x, 1 minus sine of x. That means I'm multiplying top and bottom by that. When I multiply the bottom, it will give me this. So that means on the top, when I distribute this sign in these both, I'm going to have sine squared x plus sine cube of x plus I distribute this sign in those two. So I'm going to have sine squared of x and minus sine cube of x. If you notice, these will cancel out. And then I will combine those. Since I have two of those, I'm going to have 2 sine squared of x over 1 plus sine of x, 1 minus sine of x. And I want you to notice that this, that I have I have 2 already there. And there's some way that I have to make into a tangent. Well, I know that tangent squared of x is the same thing as sine of x or cosine of x. So if you notice, I already have now the sine of x squared that I need. I just need to figure out how to make the denominator part into a cosine squared of x. Well, I want you to notice that these two are conjugates of each other. And I'm going to distribute, and because they're conjugates of each other, we know that if we multiply the first times the first and the last times the last, or FOIL things out, the middle terms will cancel out. We learned that a while ago when we were working with other kind of equations. So we know 1 times 1 is 1, and then we know that sine minus that is going to be negative sine squared x. And I'm hoping that you guys remember or could see from your Pythagorean identities that we have that cosine squared of x plus sine squared of x is equal to 1. So that means if I want cosine squared of x, this, I will have 1 minus sine because all I did was subtract the signs to the other side. So now I know that 1 minus sine squared x is cosine. So now we have sine squared x over cosine squared x. And we know that sine squared of x or cosine squared of x is tangent. So now we now have tangent squared of x, which is what we needed to verify. And this is the last one that we're going to do, and you guys actually did it by yourself. So I'm going to say right now to pause it. If you were absent, work it out by yourself before I reveal the answer and work it out. Okay, so if we move this over, again, you'll notice that I changed the tangent to sine over cosine. I put a 1 under there so that I could easily see that it's going to be this part right here multiplied together. So now sine of x and cosine of x become this. And if you notice now both have a denominator or cosine of x, that means this allows me to make the top part into one big fraction, which I did here. And now that I have sine of x cosine x plus sine of x over that, I'm going to keep the top part, change this division sign into multiplication, and take the reciprocal of the bottom part, which we get here. And then for step 5, I want you to notice that these both have a sine of x. That means I can factor the sine of x out right here. And now anything on the numerator reduces with anything in the denominator. Since these two are the same, we could reduce these to 1. And then on the numerator, all I have left is now sine of x. And the denominator, all I have is cosine x. And we all know that sine of x over cosine x is one of our identities, which equals tangent of x. And we have verified.